So this is about Sri Lankan districts. So right click on the Sri Lankan districts and go to properties, and you can find the properties, layer properties tab. In the layer properties, you can go to the symbology. In symbology, for very first we have to go to the quantiles. Okay, so first of all we have to select the quantiles. In the quantiles you can find the graduated colors. So for the value, so as you see that you can select the values according to the field's name. Okay, so according in the attribute table you can find the columns, the title of the columns as field name. So those name of the fields are listed here. So especially for the graduated colors, so you can choose either so first of all, so for the graduated color, so I'm just choosing one of these. So I'm choosing a particular year, so it is mainly based on the digits. Okay, so the numerical values. So according to the numerical values you are going to assign. So I'm just selecting the population. So here this province decode ID, these the province C, it is mainly focusing on the text based, and decode also, it is also more or less text based. So to have some variation, it is better to go with the population. So these are the population data, and here this male 2010, female 2010, those everything is based on the population. So I'm just selecting 1 year, and once you selected the year you can find a color ramp. So according to your wish you can assign your preference color. So this is the label. So the label means the classes which will be shown in your table of contents. So since I'm just choosing this color, so the lowest one will be red color and highest one in the blue color. So if I click OK, so the population in 1963 will be assigned according to the digits. Okay, so but these digits might be quite confusing, right? Why? Because usually it would be harder to distinguish the number of digits. Sometimes if it is 30,000, so instead of 30,000 we may misinterpret that as 300,000 or 3,000. So to avoid that confusion, what can we do? The label here, the range you can find here, but the label means the class which will be shown in your table of contents. So here, so the 30,000 to 69,000 is the lowest one, so I'm just assigning the lowest. So the next one will be the low, and the third one is the mid, and the fourth one is high, and the fifth one is highest. So likewise you can assign. And also the classification here, usually the ArcGIS default function about the classification is natural breaks, but instead of natural breaks you can go for the further classification. So there are so many classifications. So manual classification, manual means you can manually divide each and every classes. Equal interval means you can equally divide the entire interval by equal number. And define interval, you are going to assign an interval definition, so that will be the definition for the entire interval. So that interval will be again and again will be produced. Okay, and quantiles, so in the mathematical calculation quantiles also there, and the natural breaks and geometric intervals, so standard deviation. So there are so many classifications there. So usually in ArcGIS we are using the natural breaks as the default one. And the classes, according to your wish you can assign classes. So you can go up to 2 class, and you can start from 2 class. 1 class, it is not, that's not making any sense. So it's better to go more than 1, so starts from 2, so I'm just already have assigned 5, so I'm just keeping it as 5 and click OK. So here, since I've already made some changes with I didn't make any changes, but I went through some alternatives to show, so that's why the label again changed. So again, I'm just changing it as lower, low, mid, higher, high, and the higher. Okay, and you can change the color ramp according to your wish. So it's already been assigned in this color, but you can change according to your wish. And the spectrum order. So initially the lower color is being defined by the red color and the higher one in blue color, but you can change the spectrum order, you can flip it. Okay, so if you click on the symbol, you can flip symbol. So if you click the flip symbol, so the blue color will be denoted by the lower population and the red color will be denoted by the higher population. So it's up to you. Okay, so I'm just keeping as it is and click OK. So if you click OK, so here previously the numerical values were there, now it is being replaced by the text denotations, right? So this is about graduated colors. Then next one is the graduated symbols. So graduated symbols also, it is more or less similar to the graduated colors, but here what we are going to do is, here we are using symbols, right? So in a particular background we are using symbols. So these are the symbols that's been used. Okay, we can change the symbols, shape of the symbols according to our wish. So if the lower is there, so the label also, it's not been changed since we are already assigned. So lower will be in the smaller number and higher will be in the highest, so smaller in size and higher will be in the increased size. And you can define the background color. So I am changing the background color to this color. If you click OK, then so it's better to assign the background outline color in a definite color, then only we can distinguish properly. Okay, so this is how. So see, you can see in these districts especially, Mannar and these districts are very lower population than the Colombo and Gampaha districts. So this is how the graduated symbol works. So graduated colors, the population variation is shown in color, but the graduated symbol, more or less same thing, but the symbol is being graduated. Okay, gradually increasing according to the increment of the population. The next case is about proportional symbol. So that is quite different from the graduated colors and the graduated symbol. Okay, so graduated colors and graduated symbols is more or less graduation, but the proportional means we are going to show some proportion. Okay, so I'm just selecting a particular the same year, so that would be easy for you for the understanding. So the minimum value will be denoted by this small, and the maximum value will be denoted by this increased level. So the number of symbols to display in the legend, so initially by default it takes as 3, so I'm just keeping as it is. So please go. So if very small dot is there, so that denotes 10,000 population. The medium one is there, so in this district, so it's a medium one, so the Polonnaruwa district, so this shows 100,000. So see that Colombo and Gampaha, this is denoting 1 million. So likewise, so you can increase the classes also, the legend, the number of symbols to display in the legend, you can increase it up to 5. So if you increased 10,000, 50,000, 100,000, 500,000 and 1 million, so the least one would be the 10,000, and the highest one will be the 1 million, but the in between values will be divided according to the numbers of legends that we assigning at the initial level. Okay, so this is about proportional symbols, and next is about dot density. For the dot density, it is quite different from the proportional symbol. Okay, but here what we are going to assign. So first you have to select a particular population. Just click this arrow button, so it will go to this field, so which is the field is going to assign the population. So I'm just showing this one here, and the minimum value will be shown in this manner. Mean value will be shown in this. If the dots are sparsely distributed, that is the minimum. If it is densely distributed, it is the maximum. So this is how it is going to be. So I'm just you can select the color ramp according to which I'm just keeping as it is, then click OK. So see, so one dot, it shows 10,000 population. That means just assume this district, so it holds nearly 1, 2, 3. So just assume, so this district's population in 1963 is about 30,000. Just assume. So the dots, according to the dots visibility, I'm just telling. So 1, 2, 3 dots. So it is about 30,000 to in between 30,000 to 40,000. Okay, but see here in the Colombo district, so it is more than that. It is more than 20, we can say. So according to, we can count the dots, and we can say the number of population, okay, from this. So that is what we call as dot density. So each dot denotes by the particular value. So you can change this value. So you can change one dot represent 20,000. Okay, so if it is 20,000, so see, than the previous value. So these values are bit more sparsely distributed than the previous. So since it is previously it is about 1 dot represent 10,000, now it is representing 20,000. So if that changes, the dots also will be sparsely distributed. If I reduce the value as 1 dot represent 5,000, that the new map will be much more densely densely applied. Okay, so the same districts I'm taking. Okay, so here 2. Okay, 2 means 20,000. So if we take initially the 40,000 is the initially 4 dots. Okay, so initial dots are 4, so that's 40,000. Now we just changed as 20,000. So from that, now it is 2 dots, so it is again 40,000, but the number of dot it is being represented by the population is been changing as we are changing the values. So again go to the properties. So this is how the quantiles is being assigned. So graduated colors and symbols more or less similar. Graduated colors, the population, the increment or decrement will be gradually shown by colors and by symbols also. Proportional symbols, it is on proportion to another, it has been shown. And dot density, according to the number of dots being assigned, the population can be determined. And the charts, so for the pie chart, it is always advisable to select more than 3 population 3 years or 3 numerical value based sizes, and click OK. So you can see, so each and every district, so how the population is been changing. Okay, so you can find from these charts. Okay, so for the pie chart, because if you assign just 2 years, you won't get much more variation, especially in terms of pie chart. See, it is, you can find some variation, but somewhat it is quite uniform, you know. For this area is quite different in this than this area, and this area is quite different, but more or less similar. So that's why it is always better to go more than 2. Okay, but having two also fine. It depends on your need, how we are just assigning. Then we'll go to the bar. So bar also, bar you can select more than one. So it is always that is only then only we can show it in a proper way, more than one. Okay, then I'm just applying. Okay, so this is how it has been shown. So compare with the pie chart. Okay, so bar chart is much more you know much more presenting the idea a bit clear. Okay, and so I can show you in a different way. So instead of taking 2 years, I'm just taking male and female population in the 2010. In 2010, so I'm just taking, so this is much more it depicts the bit more clear picture. So in a particular year, how the population of gender changes. Okay, so the same thing we can assign. So this is for the bar chart, and the stacked one means that is on another. So bar, it is next to another, so male population is next to female population, like this. But stack chart is male population on the female population, or the female population on the male population. So it depends. So this is what we call it as stack charts. Okay, so there are differences in the each and every charts: pie chart, bar chart, stack charts. So if you are going to show the differentiation in two, um, uh, especially two field. Okay, if you're choosing two field, so it is always better to go with the bar chart. And pie chart, it's better to go more than two, and stacked also, it's up to your preference. Okay, so likewise you can use this layer property, especially the symbology, for your betterment of the results that you are getting. Okay.